Who is online? Yeah, who is connected by now? Good evening to you, everybody. Siluni is there. Who else? Siluni is there. Who else? Situmya. As usual. Shall we start the lesson then? අයිබෝන් ළමයි. ඔයගොල්ලෝ හැමෝම සුවෙන් ඇති කියලා බලාපොරොත්තු වෙනවා. Yeah, Kavisha is also there. Good evening to everybody who was connected, disconnected, right? And we were doing limits, and we came to some important point in limits, right? Finding the limit of some rational functions. Sometimes, like at first sight, it looks like you're going to get say 0 over 0, 0 over infinity, infinity over 0, infinity over infinity. So you sometimes you see you're going to get them, right? So you see you're going to get something like this. So you have to avoid these situations in finding limits, right? And by last lesson we have discussed the two of them. So altogether there are four that we are going to do. We have discussed two of them, and I gave we have done some examples also, and These are these five, and I give you more for homework. Shall we see your answers? With the answers, we can discuss the method also. Now, to find the limit of rational function like this, a polynomial divided by another polynomial, as x goes to positive infinity or negative infinity. So you know that if you try to find the numerator and denominator separately, limit of the denominator and limit of the numerator separately, so you will get infinity over infinity. So it's there is no meaning, right? But our method to avoid that and to find the exact limit, our method is uh, to consider only the highest power terms in both the numerator and the denominator, right? So in this particular problem, so as x goes to infinity, you take 3x squared, the highest power term in the numerator divided by the highest power term in the denominator, and x square will cancel off, giving limit as x goes to infinity 3 over x. As x goes to positive infinity, clearly it is 0, right? So it is equal to 0, right? And the next question I gave you, right? Limit as x goes to negative infinity, you take the highest power terms in both the numerator and denominator, so that will be x cube over 3x cube. They are the respective highest power x terms. X cube over 3x cube. So you can add these things. These x cube terms will cancel off, leaving just 1 over 3. Limit as x goes to negative infinity, it's 1 over 3. Negative infinity or positive infinity, wherever x goes, this 1 over 3 is a constant, right? So it will remain at 1 over 3. It's fixed. So it is 1 over 3. Right? Now coming to this, limit as x goes to negative infinity again. You take the highest power terms in the denominator and the numerator. The numerator highest power term is 2x to the power 4 divided by 3x squared. Right? And x square will cancel off, leaving limit as x goes to negative infinity 2x squared. 2x squared. X goes to negative infinity, but it's x square remaining. So whatever x other than 0, whatever x is other than 0, x square will be positive. So as x goes to negative infinity, this will go to positive infinity. So the limit is positive infinity. Right? The next, limit as x goes to infinity. So what are the highest power terms in the denominator and the numerator? The numerator highest power term is minus 6x squared. Minus 6x squared. Divided by the denominator highest power x term is 4x squared. Still the x square terms get cancelled, leaving minus 6 over 4. So you can simplify it, w minus 3 over 2. Limit as x goes to infinity, that will be minus 3 over 2. Again, it's a fixed value, minus 3 over 2. So wherever x goes, it will remain at minus 3 over 2. So that's the limit, right? And the fifth, You take the respective highest power terms in the denominator and the numerator. The numerator highest power term is minus 6x to the power 5 divided by 3x cubed. Yeah, denominator highest power term is 3x cubed. Again, an x square will cancel off. So that will give. So that will give. I take the minus one out. Minus limit as x goes to infinity. It's 6 over 3. That will be just 2. 2x squared. 2x squared. As x goes to infinity, 2x squared will go to positive infinity. But you have minus 1 in front of. Therefore, as a whole, it will go to negative infinity. So the limit is negative infinity. So these are the answers for first 5 questions. You can check the answers and make any correction if needed. Okay, shall we go to the other questions that I gave homework? Question number 6 is this. So this is the first method that we learned, how to find the limit of a rational function as x goes to positive infinity or negative infinity. Then we learned a second method also. The other questions were given from the second method. Right, question number 6 is this. Limit as x goes to 0, root of 4 plus x squared, 4 plus x squared minus 2 divided by x squared. This is the question. Yeah, this is the next question. And our method is, in a case like this, we said, especially to deal with this square root thing, we said our method is we multiply and divide by changing the sign in the middle here and making it plus 2, and you multiply and divide by that. So this will be multiplied and divided by this. Changing the sign here, root of 4 plus x squared plus 2 divided by root of 4 plus x squared plus 2. Right? And now we see in this that this is a that product is difference of squares. Hmm? Difference of squares. And we can write it as a difference of squares. And this no harm from this. So we can take this part, this plus here, we can take it separately, and the other things we will take separately. Okay. So that's the lesson. That's the method we did last day. Fx goes to 0. Here, this part is difference of squares. Square of this minus square of this. 4 plus x squared minus 2 squared. That will be 4. Divided by the denominator is x squared. Right? And at the same time, we will write the other part. This one, we'll take it separately with the limit. As x goes to 0, this part will remain 1 over root of 4 plus x squared plus 2. Right? Here, 4 will cancel off, leaving for the moment x squared over x squared, and limit x goes to 0, w x squared over x squared. So as we said earlier, no problem with this. You can take the limit of this part directly. As x goes to 0, that will give 2 plus 2. That means 1 over 4. 1 over 4. In this, we want to see what happens as x goes to 0, right? Not at x equals 0. So if you remember, we just discussed many times, limit as x goes to 0 does not mean anything happening at 0, right? So we don't want to see what happens at 0, but only as x tends to 0. So saying x is not equal to 0, we can cancel this. These two will get cancelled. And leaving just 1 there. So it will be 1 into 104. Finally, the answer is 104. This is the limit, right? ඔකට ඕනක් කාට හරි ලියා ගන්නටත් කාලා Okay, shall we go to the next example? Next homework question. Limit as x goes to 0, root of x plus 5 minus root 5 divided by root of x plus 9 minus 3. That's x goes to 0. Yeah. Okay. So our method now, because there is square root in the denominator, we change the sign here in the middle and multiply and divide by that. Root of x plus 5 minus root 5 divided by root of x plus 9 minus 3. We multiply and divide by, change the sign of this, making it plus here. Root of x plus 9 plus 3 divided by root of x plus 9 plus 3. Again we have another problem here. There is another square root thing in the numerator. To deal with that, we multiply and divide by changing the sign in the middle of this, right? Making it plus here, we multiply and divide again by that. This time by root of x plus 5 plus root 5 and divide by the same. Now we can take these two together, difference of squares, and these two together, difference of squares again, leaving this term and this term, no harm with them, so we will take them separately. Then we will limit as x goes to 0. These two difference of squares will be x plus 5 minus 5. Numerator divided by these two, again difference of square, will give x plus 9 minus square of 3, that will be 9. Into, as we said, for the other two parts, we can take the limit separately. So this and this, root of x plus 9 plus 3 divided by root of x plus 5 plus root 5. Right? Here, in this first 5 gets cancelled and then 9, leaving just x over x. Right? Limit as x goes to 0, x over x. And as we said earlier, we can take the limit of this part separately. So that will give as x goes to 0, 3 plus 3, 6 divided by as x goes to 0, root 5 plus root 5 will be 2 root 5. Now, in this x get cancelled, again, say we want to see what happens as x gets closer to 0 only, right? Not at x equals 0. At x equals 0, you can't cancel things like this. Right now, x is not 0, so that will cancel off, giving limit as x goes to 0. That will be just 1 into, we can simplify this a bit, dividing it by 2, that will give 3 over root 5. So here the limit is, wherever x goes, it will be 1. 1 into 3 over root 5. So the answer is 3 over root 5. This is the answer for the second. හරි. ටක් ගාලා අඩුපාඩු තියෙනවා නම් හදාගන්න ළමයි. මම යාට දෙකක් දෙන්න. Okay, shall we go to the next question? I gave two more. ළමයි මම පස්සේ දැක්කේ අන්තිම දෙකේ පොඩි corrections තියෙනවා කරන්න. Sorry මම මේ පස්සේ දැක්කේ. පොඩි වෙනස්කම් දෙකක් තියෙනවා කරන්න. We can do them now. I'll make the corrections. You do them now. This is question number 7. Then number 8. Number 8 that has to be this. Number 7, number 8. Number 8 has to be this limit as x goes to 1. So I gave you like root of x squared plus 7. I gave you minus root 7 here. I gave you minus root 7, but it's wrong. It has to be root of 8 or 2 root 2 and divided by x minus 1. Please correct it. It has to be not root of 7. Last day by mistake I gave root of 7 here. It has to be root of 8. මම දැන් විනාඩි දෙකක් දෙන්න දැන් හදන්නම. This has to be root of 8. ඊළඟ එකෙත් ඒ වගේ පොඩි වැරද්දක් තියෙනවා. මම දැන් හදලා දෙන්නම්. Do it now, right? This has to be root of 8, not root of 7. See if you came up to this. Came up to this. Now what do you do here? When you reach here, still the problem is there. As x goes to 1, it will go to 0. This will also go to 0. It looks like 0 over 0. Now to get rid of that, but our technique is we write this as difference of squares. X minus 1, x plus 1 divided by x minus 1 into this one. Root 8 is again 2 root 2. Root 8 is 2 root 2 altogether. That gives 4 root 2, right? 2 into root 8 is 4 root 2. And here x minus 1 gets cancelled. Again, x is not equal to 1. We want to see what happens as x goes to 1, gets closer to 1, right? Okay, that will get cancelled. And as x goes to 1, leaving x plus 1, that will go to 2. 2 into 4 root 2. So altogether it is 8 root 2. Finally the answer is 8 root 2. So you can make your corrections if necessary before going to the next. Okay, go to the next. And this section, there also in the last video, there also I made a mistake. The question, in fact, is this last question, question number 9, has to be this limit as x goes to 2. I gave x minus 2, it is correct. X minus 2 numerator is correct. Divided by root of x plus 5. This is also correct. But then the next part, it was root of 5. If I am not mistaken, I wrote root of 5, but it's wrong. It has to be 3. This has to be 3. Right? Please correct it. This has to be 3, minus 3, not root 5. Okay, correct it now, and then you can do it now. I'll give time. Right? Start it now. So I worked it out. You can check your answer. So we can now go to the next method. At the beginning, we said there are 4 methods altogether. We discussed 2 methods last day. Now, today we are going to the other two. The other two are not just methods, the other two are theorems, right? The theorem. We are going to see the first theorem as the third method, and there is another. So the third method is a theorem. Right, theorem. මම අද නම් දෙක තුනක් දැක්කේ නෑ. කවුද ලිප් මල්ලි ඉන්නවද? අපේ සුජාතගේ කවිෂාගේ නම දැක්කා. කවුද අනිත් දෙන්න? චෙනුලි, කුසල්නි ඒ දෙන්න දැක්කේ නෑ. එතකොට යුස්මිගේ නම දැක්කේ නෑ. ගිය සතියේ කවුද? දිනාරා ඉන්නවද? මම දැක්කේ නෑ නම. ඔයගොල්ලන්ට ඩේටා ප්‍රශ්නෙත් ඇතිව මාසාන්තය වෙනකොට දැන් ඊළඟ මාසේ මුල වෙනකොට data package එක දාගන්න මාසෙට දාගන්න හැබැයි ෆිල්ම් බලලා ඉවර කරන්න එපා. මෙන්න සමහර අම්මලා තාත්තලා කියනවා ළමයි ෆිල්ම් බල ඉඳලා දැන් ගෙදර ඉන්නවනේ කරන්න දෙයක් නැති නිසා ෆිල්ම් බලලා data ඉවර කරගෙන කියලා. ෆිල්ම් බලන්න ඕනම නම් කවුද ඉන්නේ? චේනුලි නේද? ගන්නේ කොට කියන්නේ. ඒ නිසා මේ ෆිල්ම් බලන්න ඕනම කමක් තියනවා නම් නයිට් ටයිම් data දාගෙන බලන්න ඩේ ටයිම් ඉතුරු කරගන්න පන්ති වැඩවලට මාසෙ පුරාම. Right. Right. So the third method, as I said, is the theorem, right? So we are going to see two theorems next. Theorem. I'll use some example. Earlier, at the beginning, I gave some example like this. If you remember, somewhat similar to this, I gave you limit as x goes to 2, x to the power 5 minus 32 divided by x minus 2, right? So if you try to take the limits separately and find the denominator, of course, directly is 0. The numerator, as x goes to 2, that will also be 0. At first sight, at a glance, it will look like 0 over 0, like meaningless, right? But we can get a very nice answer for this in mathematics using the theorem. Is this theorem says, right? Now, how to find the limit in a case like this is the question. So, to find the limit like this theorem comes to help, right? Theorem says something similar to this. Generally, looks like x to the power n minus a to the power n over x minus a. That's the function xn minus a over x minus a. We want to take the limit as x goes to a. As x goes to a, somewhat similar to this, you see that the numerator is 0, the denominator will also be 0. It looks like 0 over 0. But we can prove that this gives a nice answer, right? Nice answer. It is, this n comes forward, n into a, n to the power n minus 1. So it's equal to n a to the power n minus 1, right? For any n rational number. For any rational power, you know that when you write a power or an index like this, it has to be rational, right? A long time ago we have discussed it. So this has to be rational. So the theorem is valid for any rational power. Any rational power. So this is the theorem. This is the theorem. Proof. Proof, better we leave it to do when we start the class normally. I don't know how long it's going to take. Balu, sati deka, tunak, මාසයක් යනකොට පන්ති පටන් ගන්න වෙයි. අපි පන්ති පටන් ගත්තම ප්‍රූෆ් එක කරමු නම. මේක දැන් මම බෝඩ් එකේ දිග ප්‍රූෆ් එකක් ලියන්න ගියොත් ස්ටෙප්ස් 3කට කරන්න ඕගොල්ලන්ට කම්මැලි වෙයි. අහගෙන ඉන්න. හරි? දැන් ප්‍රූෆ් එක කල් දාමු. You remind me to do it when we start the class normally. Till then, proof we'll postpone later. Right? Proof postpone for the later to do later. If after proof in your school term test, don't write this as the proof, right? May Kavithi Education proof later, right? On that, we'll do it later. So you can take this as an example. Take as the first example. Now remember that to use this theorem or whatever theorem in mathematics, maybe principles you learn in physics, chemistry, to apply apply this theorem to a given problem, everything should be nicely set like this. What is the form of this? X to the power n minus a to the power n divided by x minus a, and the limit as x goes to a. If everything is nicely set like this, then directly you can apply the theorem and get the result. The limit is n a n minus 1, n a to the power n minus 1. Now to find this, again at a glance, it looks like things are not really well set, right? X to the power 5, it's okay. This is not matching, but the denominator is also okay, x minus 2, as x goes to 2. Everything is like okay except for this, but you can easily fix it. Just writing this as 2 to the power 5. Replace this 32 by 2 to the power 5, then it will take the whole thing, will take the form of what you see in the theorem, right? So I'll rewrite as x goes to 2, as x goes to 2, x to the power 5. I rewrite this as minus 2 to the power 5 divided by x minus 2. Okay, now everything is nicely set. X to the power n, like that, minus a to the power n divided by x minus a as x goes to 2. As x goes to, it looks like x goes to a. Now the theorem says the limit is equal to n times a to the power n minus 1. N is 5 here. N is 5. A is 2. N minus 1. To the power n minus 1, that will be 5 minus 1. Is 2 to the power n minus 1. 16 into 5, answer is equal to 80. And that's how we use the theorem, right? Again, remember that not only for this theorem, but also anywhere if you apply a standard principle, the conditions should be conditions in the theorem or the principle should be exactly the same to use it, right? So if you got some idea from this, then I can give a few more questions for you to try. You take it down, then try these questions. Okay, you have a question? Abhita, how many pages do we have to keep for the proof? No, don't keep a space for proof. We'll do all this, and after finishing the limit, we'll leave some to. There's another proof, right? Another theorem we are going to meet. Then either the end, then just write proof. We postpone it, right? Later. Pardon me, Gurnama. There's another proof. We'll do the two proofs together, but not now. Some other day. Pardon me, Gurnama. Tiya kirti kirtu nakra. Then onne proofs dekho mega part kala. We are going to see another proof today, another theorem today. That proof also we will leave to do later on. Okay. This theorem is method 3. Okay, I have forgotten to write that. Uh, you can write method 3 and then the theorem, right? This theorem is method 3. You can check the answer for question number 2, the second sum. I worked it out. The second. Answer for number 3, you can check the answer for number 3. Anybody read number 5? Part 5? And got the answer? What about part 5? Anybody finish it and got the answer? Respond. So let's see. Part 5. So you can check the answers up to 4. Up to 4, I wrote the answers. So we can discuss the 5th. The 5th is limit x to the power 5 minus 5 x to the power 7 minus 2 to the power 7 divided by x to the power 5 minus 2 to the power 5. Right? But to apply the theorem, we need everything as nicely set as the things in the theorem. Can you apply to this directly? No, it's like x to the power 7 minus 2 to the power 7. We need x minus 2 here divided by x minus 2, not this. Right? The thing is, in mathematics, if you like to see x minus 2 here, you like to see something here, you don't see it at the moment, you just write it. So that's what we do in mathematics, right? You want to see x minus 2 here, you just write it. Simplifying your name, අපිට වර්ගය අපි ලියලා දානවා. So x to the power 7 minus 2 to the power 7, you like to see divided by x minus 2. So we just wrote it, but doing so, you like change what you have given. So we paste it, but then continue them, right? To neutralize that, you will have to multiply by x minus 2. To neutralize this, we'll multiply by x minus 2 also, right? Now like no effect of x minus 2. And there is this part, x to the power 5. There is x to the power 5 minus 2 to the power. So we can take the limit of this part separately. Limit as x goes to 2, we can take that separately, right? Now look at this. There's no problem here. It is nicely set. Everything is set to use the theorem. Xn minus a over x minus a. So we can find the answer for this directly, apply the rule, apply the theorem. This gives n minus 1, 7 into 2 to the power 6. And look at the other part. This one, it's not exactly the way we like to see it. X minus 2 divided by x to the power 5 minus 2 to the power 5. You would like to see it turned upside down. So we will make it, we will turn it upside down, but for which we will have to write it like 1 over. 1 over. You can write it turning upside down. x to the power 5 minus 2 to the power 5 divided by x minus 2. No harm done, right? And we take the limit as x goes to 2. Now that part is also okay. Now you can take the limit of this directly. It's in the required form xn minus an over x minus a as x goes to a. The thing is again set for that part also. So we will take the limit of this directly. Here we have 7 into 2 to the power 6 into 1 over this part gives similarly 5 into 2 to the power 4. 5 into 2 to the power 4. Simplifying a bit, it's 7 over 5. 7 divided by 5. You have 2 to the power 6 divided by 2 to the power 4. So that will give 2 to the power 2. So that's 4. 7 into 4. 28 divided by 5. Finally, the answer is 28. Limit is 28 over 5. So you can take it down. There's another method also to work out this. I'll give that method also. For the moment, you can correct your answer or you can take it, copy it. I'll give the second method after this. So what is the second method? My second method is, so our theorem is like x3 minus 2b minus 3 and x goes to 8. Okay, minus 1 is the theorem, right? So it's the denominator. So you can take this as x. If you take this as x and this as a, looks like x minus a we already have in the denominator. This is your x, this is a. X minus a is there. But x minus a is there. But the numerator should be written in the form xn, x to the power n minus e to the power n. So that means this has to be written as some power of this. This has to be written as some power of this. So can't we do so? We rewrite this. Denominator we keep unchanged. Then this x to the power 7 we have to write as some power of x to the power 5 minus to the power 10 we have to write as some power of 2 to the power 5. This we have to express as the power of this. So what is it? What is it? Power of what is that power? To the power 5 to the power what is it? Can Bharat? X to the power 7 as a power of x to the power 5. What is using vector? Yeah, is that 705 to the power to the power 705. You agree with this? So yes, it's all your math. 705 is correct. So it gives x to the power 7 ultimately. And so it looks like we have xn minus a n divided by x minus a. But the limit that should also be matching to this. You are given x goes to 2. That's how it is given, x goes to 2. But our new x is x to the power 5. A is 2 to the power 5. So this is not sufficient to apply the rule. But but you are given x goes to 2, then what happens to x to the power 5? If x goes to 2, x to the power 5 will go to, if x goes to 2, x to the power 5 will go to 2 to the power 5. We can change the limit. If x goes to 2, then x to the power 5 will go to 2 to the power 5. So we can change the limit also to x to the power 5 goes to 2 to the power 5. Now look at this. Now everything is nicely set to apply the theorem. Okay, minus a n divided by x minus a as x goes to 8, right? So the answer is n is 705, a is 2 to the power 5, n minus 1, 705 minus 1. So that will be clear. Okay, you can take it down, and there is one last question. You can try this. Then try last question, part 6. What is the answer for part 6? The answer for the last part? I think it's Dinara saying 99. Okay, let's see. Answer is 99. Let's see. Mm-hmm. 13 also says 99. Okay. But remember, to apply the theorem, again everything should be set correctly. So you have to check if a to the power n, a is minus 1, minus 1 to the power n, 99. Is it correct to write this? Is it correct? Can you replace x to the power 99 plus 1 with x to the power 99 minus 1 to the power 99? Is it correct to write so? Plus of this plus 1 can be replaced by minus of minus 1 to the power 99. It's correct. The denominator, you have x plus 1, but what we need is x minus a. So if I write x minus a, x minus minus 1, is it correct? Can you replace this by this? So yes, you can, because x minus minus 1 is again x plus 1. So this thing, this expression given the function, you can express in the form xn minus an over x minus a as x goes to a. Right? So it is, by the theorem, it is n a n minus 1. So 99 minus 1 to the power 98. Minus 1 to the power 98 is an even power. Minus 1 to the power some even power is plus 1. Plus 1 into 99. So finally the answer is 99. 99 is correct. Not minus 99. It has to be plus 99. Not minus. Minus 1 to the power 98. It is plus 1 into 99. It has to be plus 99. And that's our method 3. Now we can go to the fourth and final method. Fourth method is also a theorem. So what is the theorem? Fourth method is also a theorem, and this is where, so we are in calculus, we have started calculus with limits, right, with limits, and this theorem, this is where trigonometry comes into calculus. It's via this theorem, trigonometric functions connect with calculus, right? So it's a very important theorem in calculus, in limits. So method 4. Method 4 is also a theorem. It's also a theorem. Again, I gave you some hint of this earlier, if I'm not mistaken. I gave you in the previous examples to find the limit of say sin x over x as x goes to 0. So I remember I gave you something like this previously. If you try to find it directly without thinking much, yeah, if you try to find it directly, as x goes to 0, the denominator will go to 0, numerator, so it's no meaning in this, but you can prove that this gives a nice answer. Sin x over x as x goes to 0, we can show that the limit is nicely just 1. The limit is equal to 1. And that's the theorem. That's the theorem, right? Sin x over x as x goes to 0 is equal to 1. Again, the proof we will leave the proof to do later when we start the class normally. Not now. Proof ekal දාමු. මත් ඒක කරන්න. ඔයගොල්ලෝ කම්මැලි දේ ඔක මම දැන් කරන්න කියලා. And then better we start with examples. ඊට කලින් මේක ලියා ගන්න ළමයි theorem එක. To start examples. Okay, before discussing the example, see the form of this theorem, right? Theorem. Sin of some angle, sin of some angle, right? By the same angle, sin of something divided by the same, and that thing goes to 0, right? Sin of some angle divided by the same angle, and that angle goes to 0. The limit is equal to 1. Given in the theorem. Now, in this example, you have to find the sin 5x as x goes to 0. And we are like here. We have a like this set to apply that theorem. Is there some difference? If you notice that there is some problem, as x goes to 0, this is okay, but the angle is 5x. So it's right? Then if it is 5x, and it has to be verified, not x. You would like to see not x here. Angle is 5x, and it has to be 5x in the denominator, right? So we like to see 5x here. As I told earlier also, we write 5x. 5x divided by, we like to see 5x here, so I got 5. But the thing is, this 5 is something really important. Like that. visualize that when the Kavithilaka is 5 is the constant. I write it outside. Especially, right? Because it's a constant independent of x. So it can be written outside. So 5 times limit as x goes to 0 sin 5x divided by 5x. Now this one is okay. Sin 5x is 5x. But according to this figure, it has to be not just take this meaning. Just 5x goes to 0, right? But as x goes to 0, it happens to 5x. If x goes to 0, then 5x will also go to 0. So we can change this. If this is right, 5x goes to 0. No harm. Now look at this. Now we have everything nicely matching to the theorem. Sine of one angle, here by the angle, and that angle goes to 0. So on the theorem, we find 1 and that side also side of. So finally we 5 into 1 times 5. Target up din ng dahil na dito pa homework ito. look at this. You have fine poet here. You would like to see, to apply the theorem, you would like to see divided by poet. So we don't have any x here, but we need poet. So now nothing done. Now, nothing find out permanent. It's like 4x and 3x, but x already gets cancelled here. So you don't have to worry about this x, but 3 over 4 is there. 3 divided by 4. Something imported. Right? X is this x and this x, they balance each other. So no need of saying attention on x, but 3 over 4 is there. To neutralize that, I write 4 over 3. Okay? At the same time, I can take the limit of this separately. We have a theorem for that. Limit of that separately. Okay. Now there is no problem with this part. No problem with this part by our theorem. There is one problem here. There is one problem here. It find 4x divided by 4x, but given x goes to 0, but you can, without any effort, you can change it to 4x. If x goes to 0, then 4x will also go to 0, right? So we can change it to 4x goes to 0. We can change it to 3x goes to 0. Now this part is accepted fully set to use the theorem. So that will give 1. 1 into, this is, there's some difference here. It's like turned upside down, but we can again make it turned upside down by writing 1 over this thing. 1 over limit as 3x goes to 0. This part I'm writing turning upside down. It will be then sine 3x over 3x. This part you can write like this into 4 over 3. Now again this part will give, again everything is set over 3. So you have to explain things, you have to show these steps, how you use the theorem. These steps you have to show, right? You have to show how you apply the theorem. Now what about this? The last question. You need trigonometry in this. You should remember the formula trigonometry in calculus, right? Everywhere we need trigonometry. For the moment, it looks like nothing to do with our theorem, not connected with our theorem by at a glance, right? Can't we connect this with our theorem? මැකාගේ දන්න එක theorem එකයි කොහෙන් හරි ගෙනල්ලා එකට සම්බන්ධ කරගන්න ඕනේ. Hmm? What does this remind you? connect with our theorem, you should remember this thing, the half angle formula. Cos x is equal to 1 minus 2 sine squared x over 2. 2 sine squared x over 2. So 1 minus cos x, 1 minus cos x is equal to 2 sine squared x over 2. Right? So this numerator can be replaced by this. Now it looks like it is some shape. 2 sine squared x over 2 divided by x squared. Now it has some shape, but not exactly the way we need it. It's sine x over 2. We would like to see divided by x over 2. Before everything, there is square here and here also there is a square. So we can write the whole as a square of everything. And before that, we will take this 2 out. And you can write it as sine of x over 2 divided by, now square of everything divided by x over 2. Because sine x over 2, with that you would like to see x over 2 here, right? So we write that, and then the limit has to be, you are given x goes to 0, but it has to be changed to x over 2 goes to 0. Okay, and square of everything. You are given just x squared. It looks like we have written x squared over 4. The square of this, x squared over 4. This 4, square of this 2, this 4 is something very important. Fitting in Africa. So balance it, you will have to write 4 here. To balance it, you have to write 4 here. So I'll take it out. I'll take it out the limit because it's a constant. 2 divided by 4. Now you can use the theorem. This part, this whole thing is 1 by the theorem, square of 1. And this gives half. So finally, one is half into 1, so it will be equal to half. Okay, paninggan naman, mang homework ko taga nanti kat din lang. So it's like we have discussed all the basic things in limits, right? We'll have to discuss more sums, examples, past wave problems, but basically we have covered everything. Now you can try. I'll give you questions now for homework. Together with that, you can try all the past paper problems also. Any past paper question. දැන් limits වල ඉගෙන ගන්න ඕන දේවල් ඔක්කොම හරි ආ. දැන් ගණන් හදන්න පුළුවන් ඕන එකක්. මම දෙන ගණන් ටිකක් හදලා past papers වල ගණන් ටිකක් හදන්න. මම දාන ගණන් ටික මේ මොන හරි මගන්න ළමයි ඔයගොල්ලෝ ආපස්සට ඇවිල්ලා බලන්න. මම ලියාගෙන යන්න. ඔයගොල්ලන්ට පුළුවන් මේක ආපස්සට ඇදලා පොඩක් බලලා ලියා ගන්න නේද? ඔයගොල්ලෝ ඔය ටික ලියා ගන්නකම් අපි බලන් ඉන්න ඕනේ නෑනේ නේ. මම පන්තියේ වැඩ ඉවර කරනවා ළමයි. ඔයගොල්ලෝ චුට්ටක් ආපස්සට ඇදලා ගණන් ටික ලියා ගන්න. ඔය ටික හරි and you try from past papers also හරි එහෙනම් අපි අනිත් දවසේ මේකේ තියෙන ප්‍රශ්න අමාරු ඒවා ඩිස්කස් කරමු past paper questions also and if we able to finish this then we will be able to start the next topic differentiation. The next topic in calculus is differentiation. Let's see if we can start it by next lesson. හරි එහෙනම් ළමයි ඔය ගණන් ටික හදලා තියන්න. එතකන් අතට පන්ති ඉවර කරනවා. ඔයගොල්ලෝ හැමෝටම බුදු සරණයි නිරෝගී සුවය ප්‍රාර්ථනා කරනවා.